Very good afternoon. My name is Husen. I am an assistant professor at School of Engineering at P Savani University. Today we are going to study about graphs. So graphs is an important non-linear data structure which has various applications. So let us look at it now. So our topic is graphs. So as I said, it is a non-linear data structure. It is a non-linear data structure. So what do you mean by non-linear? We have linear data structures such as arrays, queues and stacks, in which we can access the successive elements. I can access the first element from the zeroth element, right? But in non-linear data structures, it is not the case. A single element can be connected to multiple elements here. So let us look at the graphs now. So we have two types of graph. One are directed graph and another one are non-directed graph. So here you can say this is a non-directed graph and it is a directed graph. What do you mean by directed and non-directed? Directed means that there is a directed edge from a node to another node. So these are called nodes. These are called nodes. And these are called edges. Edges connect to nodes. And here also this is a directed graph. This is a directed graph. And this is a non-directed graph, or I can say undirected graph. So two things make up a graph. First one is nodes. These nodes 1, 2, 3, 4, 5, and another one is edge. So edge is the thing that connects two nodes. So you can take an example of a city. A city has various places, right? It has place A, like in Bharuch we have Saktinath, then we have Bholau, then we have railway station, then we have Parsiwad. Such things we have, right? So these places are connected via roads. So roads are the edges and the places are the nodes. You can think of it like that. And these are undirected. So I can move from node 1 to node 2 and successively I can move from node 2 to node 1. So there is no restriction here. But here there is restriction that I can only move from node 1 to node 2. I can only move from node 2 to node 3. I can only move from node 3 to node 4. I can only move from node 4 to node 5 and from node 1 to node 5. So there is a restriction here. We can only move in one direction. So this was about the directed and the undirected graphs. Now let us move further and see how we can represent the graphs, how we can represent it inside the memory of a program or a process. So the title is Representation of graph. So suppose I have a graph like this. Right, and these are the nodes 1, 2, 3, 4 and 5. Now I want to represent this graph. So I have two ways. First one is adjacency matrix adjacency matrix, and second one is adjacency list. So I have two ways. First one is adjacency matrix and another one is adjacency list. So now let us see how we can represent a graph inside a adjacency matrix. So I have this graph. So I will create a n cross n matrix where n is the number of nodes. So how many nodes do I have here? 1, 2, 3, 4, 5, right? So I will create a 5 cross 5 matrix. So I will create a 5 cross 5 matrix, and inside which the first index is 1, 2, 3, 4 and 5. Here also first, second, third, fourth and fifth. So is 1 connected to 2? Yes, it is connected. So I will put a 1 here, which represents that there is an edge between 1 and 2. And similarly there is an edge between 2 and 1, so I will put 2 and 1. There is an edge between 2 and 1. Then 2 and 3, so I will put an edge here, 2, 3, 2, 3. Then 3, 4, so I will put 3, 4 and 3, 4 like this. Then 3, 5, so I will put 3, 5 and 5, 3. Then 3, 4 is done, 4, 5. So I will put 4 and 5 and 5 and 4. Then I will put 1 and 5. So 1 and 5 and 5 and 1, right? So this is the adjacency matrix, and other ones are 0. Others ones are 0. So how many edges I have? 1. For 1 I have 1, 2 and 3. So 1, 2. For 2 I have 1 and 1. So is there a problem here? I can find out there is a problem here. So first thing is 1 is connected to 2 and 5. So 2 and 5, it is not connected to 3. So there is a problem there. I will erase it from here and I will put it here, and this will be 0. So now it is fine. 1 is connected to 2 and 5, 2 is connected to 1 and 3, 3 is connected to 5 and 4, 5 and 4 and not 1. So this will be 0. This will be a 0. This will again be a 0. So now it is complete. So 3 is connected to 4 and 5, 5 is connected to 4 and 3, and 5 is connected to 1, 3 and 4, and 4 is connected to 5 and 4, 5 and 3, right. So this is the adjacency matrix. Now we will look at the adjacency list. So as the name suggests, adjacency list is an array of list. So I will write down the number of nodes 1, 2, 3, 4, 5, and in each of this index we have a list storing the adjacent nodes. So 1 have 2 and 3, so I will store 2 and 3. Then 2 have 1 and 3, so I will store 1 and 3, right. Then 3 have 2, 5 and 4, I will store 2, 5 and 4. Then 4 have 3 and 5, 4 have 3 and 5, and 5 have 1, 3 and 4, 1, 3 and 4. So this is called a adjacency list. And in all of the graph problems we will be using adjacency list. We will be using this adjacency list because this takes n square space complexity. it takes n into n space complexity, big of n into n space complexity, and this takes only order of 2 into number of edges space complexity, right. So that is the difference between adjacency list and adjacency matrix. So this is adjacency list and this is adjacency matrix. Next we will be looking upon the various traversal algorithms in graphs, which is DFS and BFS. So let's start. So traversal algorithms. First one is BFS and second one is DFS. So its full form is breadth first search, and its full form is depth first search. So as the name suggests of breadth first search, we first go across the breadth. So we start at level 1, then we go to its level 2, then from level 2 we go to its level 3, from level 3 we go to level 4, and like that. But in depth first search, we go inside the depth. So we will go from level 1 to level 2, then level 2 to level 3, level 3 to level 4, and then we will come back from level 3 to level 4, level 3 to level 2, level 2 to level 1, and we will search upon the next depth. So we will look at it with an example. So suppose I draw a graph like this. So this is a graph. We will first be looking at the breadth first search. So I will erase this. So we are looking at the breadth first search, and let me put up the node numbers. One, 2, 3, 4, 5, 6, 7 and 8. These are the node numbers. I am going to start the traversal from node 1. So traversal algorithm, what it does, it search across, it goes to all of the nodes of a graph. It searches upon all of the nodes of the graph. It traverses upon all of the nodes of the graph. Right? So I am starting with 1. Now in this BFS algorithm, we take a queue data structure. So I will take a queue data structure. This is my queue. And we take a visited array. So visited array tells you that I have whether I have visited this node or not, whether I have visited this particular node 1 or not, whether I have visited this particular node 2 or not, like that. So that is a visited array, and is a Boolean array. And I will put up the index for each of them. So first one is 0, next one is 1, then 2, then 3, then 4, then 5, then 6 and 7 and 8. Right, so this is our visited array. So first we will start the traversal from node number 1. We will start the traversal from node number 1. who are the immediate neighbors of 1, 2 and 3, right? So I will push 2 first and then 3. I will mark 1 as visited, then I will take out 2 from the queue. I will take out 2 from the queue, and 1 is now the traversal has been printed as 1. This is the first node in the traversal, so 1 has been printed. Now I have taken out 2 from the queue, so I will search upon all the neighbors of queue. So I will put 4 and 5 inside the queue, and I will print 2 first, and I will mark it as visited. So T means visited and F means not visited. So 2 is also visited now. Next one is 3. So 3 I will mark it as visited. I will print it, and I will go across all its neighbors. So I will push 5 inside the queue, but I will only push it if it has not been visited, right? So when we take 2, we will go across all its neighbors, that is 4 and 5. In that case, we will mark 4 and 5 as visited. So we will not push 5 again into the queue. So we will print 3 and that's it. Next one we will take 4. So 4 has been taken out, and we will push all of its neighbor inside the queue. So 6. So this will be through. 4 will be printed, and next one is 5. So 5 will take it out, and will push all of its neighbor inside the queue, which are 7 and 8. We'll print 5. We'll mark it as true. Next one is 6 inside the queue. Next one is 6. So we'll take out 6. We'll print it, and we'll mark it as true. Next one is 7. So we will take out 7. We'll mark it as true, and we will print it. And next one is 8. So we will mark it as visited. We will print it, and that's it. Queue is empty now. Since the queue is empty, we can stop the process, and our traversal has been 1, 2, 3, 4, 5, 6, 7, 8. This has been our traversal. So this was breadth first search. First we went across level 0, then level 1. So 2 and 3 are of level 1, then 4 and 5. So 4 and 5 are level 2, then 6, 7 and 8. They are at level 3. So this is how we use BFS to traverse a graph. So next, let us look at DFS. So we will try to use the same graph as BFS. So I will draw the graph. So this was an edge, and then 7, 8, and here there was 6. So this is the same graph as the BFS. So you will see now how the traversal changes. So now we are looking at the DFS. So for DFS we use recursion. So first I will write down the code for it. So void DFS adjacency list and node and visited array. These 3 things we will take. We will mark the node as visited at the top, Then we will move across all the if we have not visited that adjacent node, we will visit it. ADJ, and next one is AD, and next one is visited. So this AD is same as this AD, which is adjacent node of this particular node. So this is the code for it. Now let us implement or execute this code on this graph. So first one is node 1. First one is node 1. Next one is, we will go to its adjacent node, which is 2. So we will go to 2. First we will print 1 and then we will go to 2. From 2 we will go to 4. From 4 we will go to 6. We will print all this in order. So 1, 2, 4, 6. And since there is no depth of 6, so we will move back. So we will move back from 6 to 4, from 4 to 2, and from 2 to 1. When we come back to 2, we will search upon its next depth, which is 5. So I will write down so from 2 we will go to 5. So I will print 5 next, and from 5 we will go to 7. And since there is no depth of 7, I will move back. So I will move back from 7 to 5, and then from 5 I will move to 8. Since there is one depth left. Since there is no depth of 8, I will move back. So I will move back to 5. From 5 I will move back to 3. So I will print 7, 8 and then 3, and then from 3 I will move back to 1. So this is the depth first traversal order, DFS traversal order. So in BFS it was 1, 2, 3, 4, 5, 6, 7, 8, and in DFS it is 1, 2, 4, 6, 5, 7, 8, 3. So this is how these two algorithms behave differently. So one uses recursion and another one uses the Q data structure. BFS uses Q data structure and DFS uses the recursion. So that's it for today's class. Thank you so much. Thank you for attending my lecture.